50% of the teacher's desk is covered in student exams. What is the probability of spilling coffee on one of them? Half and half. You get it? You add half and half to the coffee, light cream. Don't? Okay. All right. So today we're talking about geometric probability. So we know about geometry, and what is probability? Probability is a number between 0 and 1, or 0% and 100%, that tells you how likely something is to happen. If the value is 0, that means it is impossible. So let's think of something impossible. I know. Mrs. Overman is going to become a supermodel. Yeah, I think that's impossible. All right. What is the probability? If the probability is 1, then something is certain. It's definitely going to happen. So something that is certain, well, we're pretty certain that the sun will come up tomorrow. So we're pretty good with that one. We'll stick with that as certain. Halfway between 0 and 1 is equally likely. So it could happen and it might not happen. Now, you can say in this category between 0 and a half is unlikely, and it gets more unlikely as you get to impossible. Above 50%, it gets likely and very likely. So the probability of you having homework in geometry class is very likely, and it's almost certain. So to calculate a probability, you find the ratio of favorable outcomes, what you want, or what you're looking for, sometimes you don't want it, to the total outcomes, so everything that can happen. Now there's a neat word with probability. You learned about it in 6th grade. It's called complement. And complement comes from the word complete. If you ever heard the phrase, oh, that really complements your outfit, that means it completes the outfit. It stands for the rest of the outcomes. So that's going to complete all the total possible. The complement usually includes the word not. So the probability of an event plus the probability of its complement always add up to 1. So for example, the probability of having a quiz today, you could say, is 25%. And the probability of not having a quiz would be 75%. They have to add up to 1. Now, what we'll be working with in geometry is what's called geometric probability. And that's the probability of an event based on a ratio of geometric measures such as length or area. And we're primarily going to be talking about area. So, in example 1, I actually pulled this from one of my old 6th grade worksheets. What is the probability that the spinner would land on the triangle? Now, when I did this in 6th grade, we're really looking at the area. And the mistake that some of the kids would make is they'd say, oh, it's 1 out of 3, because a triangle's one thing out of 3 things. But in reality, you can see the square takes up half the area. So what I would teach my kiddos to do is I'd say, okay, go ahead and make equal pieces. And you can see that the triangle, the probability of the triangle is not actually 1/3. It's 1 out of 4 pieces. Now, how do we write that? We write P with parentheses, and I'm using triangle to symbolize triangle, equals 1 out of 4. You can also write that in percent. So in this case, it'd be 25%. What is the probability of the complement, in other words, to landing on the triangle? In other words, not landing on the triangle. So I would just take 100% minus 1/4, or 1 minus 1/4, and I would get 3/4, or 75%. In example 2, now we're getting a little closer to what we're going to be dealing with in geometric probability. If you randomly choose a point in the circle with a radius of 7 centimeters, what is the probability that it will be in the triangle? So I'm trying to find out what is the probability my point will be in here. You can see it's allowed to land anywhere in this circle. So the first thing I need to do is figure out, it's going to be the ratio of this area to the whole area. So the probability of the triangle is the area of the triangle over the area of the circle. I did see that's a little circle there. So I'm going to find the area of the triangle, and that's 1/2 base times height. Well, the base is 14. How do I know that? Well, this height here is 7, and that's the radius. And this is the radius, that's 7, and that's 7. So the whole base of my triangle is 14. Substituting in, and I get the area of the triangle is 49 centimeters squared. Now I have to find the area of the whole circle. So I know my radius is 7, and I'm trying to find the areas of the circles pi r squared. So since the radius is 7, I substitute, and I get pi times 7 squared, which is 49. And then I find the probability by putting the area of the circle over the area of the triangle over the area of the whole circle, which is 49 over 49 pi. By the way, that's just 1 over pi. And when I use my calculator, I get a value of 0.3183, et cetera, et cetera. And rounding that, I get 0.32 or 32%. Now, what is the probability that it won't be in the triangle? So that means it can't, if 32% is the probability it will be in the triangle, I can use the fact that this is the complement because there's a not in here, right there, and subtract from 1. So the probability of not the triangle is 1 minus 0.32 or 0.68 or 68%. In example 3, we're looking at a skydiver who jumps from an airplane and parachutes down to this 70 by 100 meter field. And the question is, what is the probability that he won't land in any of these targets? So if he lands out here, he can land there. So pretty much anywhere but inside the circle, the triangle, or the square. Even right there doesn't count. So how can we find this? First of all, the total area I need to find, and that's the area of the field. 70 times 100 is 7,000 meters squared. Now, the next thing I should do to make my life easier is find the area of each of these 3 shapes. We'll start with the area of the triangle, and it's 1/2 base times height. 1/2 times 10 times 20 is 100 meters squared. Now I'll do the square. 25 times 25 is 625 meters squared. Now I'll do the circle, and I use the formula pi r squared, or pi times 20 squared, or 400 pi. Now, if I want it to land in this yellow area here, I need to take away the triangle, the circle, and the square from the whole area of the field. So the way I'm going to find the probability is I'm going to take the difference between the rectangle and all 3 of the shapes. So I have this right here, and then divide by the total area. Substituting in, I have 7,000 minus 100 minus 625 minus 400 pi, all over 7,000. Now, if you're doing this with your calculator, you probably want to put a parenthesis around here, or the calculator will only divide the 400 pi by 7,000, just to let you know. So I substituted that in, and I got 0.7169, or 0.717 when I round it, or 71 7/7%, which means that it's pretty likely that he will not hit any of the targets if he's jumping in randomly. Example 4 is our last example, and here I have a restaurant. They're having a promotion. You get a free prize. Everybody gets to play, and you get to throw a dart at the board, and depending on where the dart lands determines your prize. They have this area right here, and that's a free soda, and you can see it's actually taking up this top and bottom part. So this is all free soda. In the center is free fries, and then they have 2 smaller circles for free burgers. So now I want to know what percentage of the customers will win a free burger. That's another way of saying what is the probability. So I'm going to find the area of the whole target, and that's going to be pi r squared since it's a circle. The whole radius from here to here is 4 units long. So that's from here to there. So you have 2 units, 1 unit, plus there's an unwritten 1 unit there. Squaring that, I can find the area of the target is 16 pi. Now I'm going to find the area for the burgers. I have 2 circles which have a radius of 1. So I'm going to go ahead and just say 2 circles, so that comes from having 2 circles, times pi r squared. 2 times pi times 1 squared is just 2 pi. To find the probability, I do a ratio of the burger area over the whole area. And I get 2 pi over 16 pi. This simplifies. The pi and the pi simplify. And then I have 2 over 16, which is 1/8. Using your calculator, you get 0.125 or 12.5%. Now I want to find out the probability of free fries. So I need to find this area right here. Well, first of all, the area is it's a circle, so I'm going to use pi r squared. Area of fries is pi times 2 squared, or 4 pi. And the whole area is not changed. It's still 16 pi, so I go 4 pi over 16 pi. These simplify. Pi divided by pi is 1, so I have 4 over 16. 4 over 16 is 1/4, or 0.25, which gives me 25%. Finally, I want to find the area for the free soda, which is all this outside of these two here. So what I need to do is take this whole big area, subtract the burger area and the free fries area. And you can see that's my plan. Area of the target minus area for burger minus area for fries. I take my answers, subtract out, and I get 10 pi is the area for the free small soda. To find the probability, I'm going to have to put 10 pi over the 16 pi. These two simplify. Pi divided by pi is 1, and you have 5/8. Using your calculator, you get 0.625 or 62.5%. So the area outside those smaller circles, the free small soda, is actually the biggest of the pieces of the area.